So we're now going to move on to the next part, which refers to 2e. And we're going to see the words variance and standard deviation pop up later. So what's going on here? Well, if we were looking at the distribution, so we were looking at how, here this is IQs, how IQs were distributed in some classes. We might look at these and we might quickly perhaps conclude that the median, and it looks like also the mean, may be the same in these classes. But clearly, there's a lot of people by the middle in this group, whereas it's far more evenly distributed here. And you've got sort of more data that is away from the middle, whereas here, lots of data is in the middle. So there's fewer pieces that are further away from it. Okay. So if we wanted to sort of see this with our data, we might be looking more at measuring spread, and variance is one way of doing that. So there's multiple different ways of writing what variance is. Here's one idea. So variance, and this is how variance is written. Okay, so omega squared. Distance from the mean, let's think about what that is earlier. The mean, remember, is denoted by this. So distance from the mean looks like this. Your piece of data, the mean, the takeaway means the difference. So distance from the mean sort of looks like difference here. And then we're going to square this, okay? Think about if we have a negative number overall in the brackets or a positive number, okay? Either way, when this is squared, this will turn into a positive value, the whole thing so far. And then the next step is we look at, we've done the distance from the mean, we've done the squared distance from the mean. Let's look at the average squared distance from the mean. So average, thinking about what you did when you were calculating ordinary mean earlier. Sorry, I should have said lowercase sigma, not omega. Thinking about averages, perhaps this might seem familiar. When you add them all up and then you divide by how many they are, okay, hopefully the use of average makes a bit more sense. So this is one formula that you can use for variance. However, it's more common and you'll often use this in a different form. So again, variance, and we like to use this as a sort of a little mnemonic as a clue to help us remember the formula. So MSM, SM. And you're going to see lots of the same kind of words being used here. So my advice, as long as you can remember that it's M and S, and you can remember the first two parts, and the words are sort of the same, you should be okay here. So the mean of the squares is about squaring numbers. Mean is about adding them all up and dividing by how many there are. So the first part's going to look like this. The squares, and then the mean, we add them together, we divide by how many there are. That takes care of M and S. So then there's another M. What could the M be about? Well, the M is about the minus. What's left? So the same kind of words being used. The square of the mean. We know that mean looks like this. So perhaps we need to square this value. So it looks something a little bit like this. And this here, okay, this value, the way it's written, really we're saying we have the mean and then we square it. Please do not be confused with this because this has a different meaning. And you don't need to know how to do this, but you may be interested to see that you can take the form from before, expand out brackets, play around and things, and you will actually get to this form here. So this is how you're going to find variance. By using this formula, substituting numbers in. Some of these numbers you may be given in the question, or you may calculate, you may read some of these from your calculators as well, but you need to know how to work this out. And interestingly, once you've worked out variance, you actually can do something called standard deviation as well. And more questions will probably ask you about this one. All you do is you get your answer from before and you square root it. And what this can be thought of roughly as the average distance from the mean. So the standard deviation is a property of data, and it tells you on average how far away the pieces of data are from the mean. So let's do a quick example. So using these two pieces of information, what would we get? Well, we have, in fact, let's write it out. So M, S, M, S, M. So let's see if you can remember it. So we have something on the left minus something on the right. So mean square, so the mean of the squares. So x squared, sigma x squared over n. These are the squares. This is the mean of the squares minus the square of the means. So if I do x squared, well, that's like 9 and 121. That's x squared. If I add them all up together, what will I get? I'll get 130. If I divide it by pieces of data, well, there's 2. So hopefully you can see there, I will get 65. This term on the left is 65. The minus sign carries through, and the mean, 3 plus 11 is 14, divided by 2, so 7 squared is 16. Okay, standard deviation, we would say that this is 4. And you can see here, 4 is a very sensible answer. We said standard deviation sort of means the distance from the mean. 3 is 4 from the mean, but 11 is also 4 from the mean. If we repeat this with a harder set of numbers, so if we square these, 4, 9, 9, 25, 49. If we add these all together and divide by how many there are, so what are we going to get here roughly? 75, 74, okay, 83, 92, 96, 5 pieces of data, okay, so I'm thinking 19.2, okay, and I could find the mean and work this out. And for standard deviation, I could square root it. So, a couple more examples for you on the board. Please just check that you can get these results as well. And it's worth showing you at this moment that you can use your calculators here. So let's verify that we can get these values. If I go back to options here, in fact, let's clear the screen. Menu, statistics, variable. Let's put these numbers in, 2, 4, and 6. Clear this. If I press options and 2 here, okay, where is this information? Well, that sigma squared x and sigma x, can you see that these correspond to these values I've got? So 2.6 recurring, or 2.67 is my variance, and the one that does not have the squared, okay, is the standard deviation. So your calculator's telling you means, telling you sigma x squared, okay, this is part of your calculation, isn't it? So sigma x squared is your is part of your MS. So we can get the values for our calculations from the calculator, okay, that are clear, as well as working out the final answer. So we should have the fraction that shows our working. Okay, so we're almost there. We can also extend this as well to frequency and group frequency tables. So the notation just changes slightly again, and we could perhaps use that frequency button on our calculator to do these. An example of a question. So what often happens in a question is you are actually given part of the information. So if we remember again, we have sigma fx squared here. Okay, this just means you have your values, but you're multiplying by the frequency as well. Okay, I could put sigma f instead of n. Okay, so if I wanted to substitute in here, what's happening? Well, this, just quickly read the question, and hopefully you can see that x, the thing that we're looking at here, is t instead. And this bit of information has been given. So the idea is, in this question, they would like you to use this number given. So we have that. Adding up all the frequencies, well, we can do that with these numbers here. Okay, and the mean, we don't have the mean, but if we check the question says estimate the mean and standard deviation for 5 marks. So you can sort of see a pattern with these questions. Often they will ask you to estimate the mean using techniques we have talked about earlier in the PowerPoint. Okay, so this would be by using midpoints, and you can use calculators to quickly do that. And then you can use that to actually substitute it in to find the variance. This is the variance, and then the standard deviation. So calculation should look like this for estimated mean. Okay, like this for variance, and then we can square root this. And again, you can check all of this on your calculator. Ensure that you have activated the frequency mode, okay, for when you are using midpoints, and you can quickly check your answers to this as well, okay, which is what we discussed before. So each time think about how you can use the calculator. You may need to change the mode if you have something like this, okay, and if things are grouped, you will often need to use midpoints. Another question on the board for you just to check. And again, we're being provided with some pieces of information here, but also here. So you could fairly quickly estimate the mean. The mean, we're going to have this one divided by 70. The standard deviation, well, if we start with the variance, we're going to have this number divided by sigma f, which is 70, okay, minus the answer right at the start, squared, and square rooting to get from variance to standard deviation. Okay, so 10.8. Using this here, using our number of 10.8 in here, okay, and so on. And that takes you to the exercise questions for 2E.